Hi, I am Sam Guan with Siemens Digital Industry Software. Today, I will demonstrate the functions and capabilities within our Designcenter NX Structure Designer in building a frame structure. We'll recreate a platform for this battery assembly. This platform will be used for inspection with mounted sensors and scanners to support this automated assembly process. As we review the automation of the robotic arms in grabbing the battery components and assemble them into this tray for the programmed manufacturing process. The design objectives are to recreate the frame structure for this platform and with all the detailed manufacturing information. The platform display in red at the center of the assembly layout was a result of a scanned data using polygon modeling technique. We can convert them into convergent bodies and be able to obtain relevant information. In Designcenter NX, I have to scan data on a specified layer, then using the Structure Designer, starting a new structure, activate Frame 3D command, selecting basic structure from a 3D sketch options, users can quickly create a 3D sketch. Select the 3D sketch command, I can create duplicate 3D sketch curves that conform to design. Using the create dimension option, now I can control precise distance between each of the frame structures. Same as standard sketch. Users need to pay attention which side the sketch curve will move when editing the value. Using a 3D sketch can create other types of sketch curves by selecting control points, manipulating distance or angle, rotating the handle to 45 degrees, drag the handle to extend each curve to meet up with other sketch curves. Users can view the 3D sketch results in the Structure Designer Navigator tab under the Construction Curve folder. Users activate the Create 3D Sketch. I will now create 3D frame members with the proper edge trims. Select the member option and navigate to the appropriate frame. There are many out-of-the-box frame options. They are L-angle, C-channel, flat bar, hex bar, HP bar, I-beam, round, rectangular, square tubes, and T-bars. Top of the frame will be rectangular tubes and I-beam. The vertical support frame will be in the square tubes. Each tube width option is the same. This is for the ease of assembly weldments. And note, most of the edges are properly trimmed to the desired manufacturing outcome. When we are finishing creating the frame members, we noticed that some of the frame edges are not properly trimmed. Using corner command, then selecting the join node from the corner definition display window. Users be able to choose from the trim option in the corner type column. Some of these options in the drop-down will be able to support the proper trimming. Once these updates are completed, we will now add rectangular pads to the base of the frame. Selecting different width and length will provide space for weldments of the pads and mounting space for these pads on the floor. Once we see all the frame members are created and are properly trimmed, let's do a visual review of the newly created frame members in comparison to the scanned data that is in a different layer. Once we are satisfied that our newly created frame design matches the scanned data, we will now develop manufacturing options and proper information in the form of 2D drawings. When these frames were created, each of the frame was automatically generated with a different file name. In a closer review, we see that many of these frames are the same size, but are just located in the different positions of the assembly. Using the consolidated structure option, we can create a proper assembly build material. Once these automated process to create duplications of the frame for the build material information, and then able to use it in a 2D drawing generation. 2D drawing can be created using the traditional master model approach, or in this case, it is acceptable practice to create 2D drawing with an assembly part file. Using a drawing command within a Structure Designer, After selecting 2D drawing size, Structure Designer will automatically generate 2D drawing of each component with the proper views, and then the first sheet, adding the asymmetric view. After navigating to sheet 1, we quickly added the parts list to the sheet 1 along with a display ID balloon. In our presentation today, we demonstrated the power of Structure Designer functionalities. We're able to quickly create 3D sketch of the frame and then added all the proper frames to match a legacy scan data. Then generate the manufacturing information in the context of 2D drawing after properly consolidated the bill of material. Thank you for your time today.